Hello, good morning everybody. My name is Vishwadeep and I welcome you all on Unacademy Computer Science Channel for unlimited learning. In today's lecture, this is the second installment of stack data structure. We are going to discuss about how we can implement a queue using a stack and how many such kind of stacks are required, how more efficiently we can implement a queue using stack so that we will have minimum push and pop operations. And one more topic we are going to discuss today is if we need to implement single array multiple stacks, then how we can implement it efficiently with space utilization. तो आज आपको पास्ता खिलाएंगे. अरे हाँ, पास्ता खिलाएंगे. In that example, using that pasta example, I'll be explaining you few of the concepts. Let's get started without getting any delay. I know you are excited. I am also excited. Let's start. Before we go further, my name is Vishwadeep. I want to introduce myself first. I have written GATE multiple times in computer science. 682 was the rank in third year, final year 19, 119, 440, and there are few more ranks I am having under my belt. I went to IISc Bangalore for my masters. Other than that, I have completed another masters from BITS Pilani in the data science to learn the trending techniques, technologies, the rich experience of teaching I am having, as you can see, and these are the topics I am teaching on Unacademy's platform. If you want to learn for free more than another platform we are having for you guys, which is the Unacademy's Learner app, download it. It's a must using app for you guys if you are learners of computer science or any engineering field or any competitive exam. So if you are preparing for any competitive exam, this is the must using app for all of you. Yes, must have app. Download it. Go to my profile, follow my profile. There you will be getting special classes. Those special classes are free for you guys. Today also in the morning I have taken a special class on in which I have solved some questions of pipeline. Tomorrow again I'll be having a special class. What time? 8:30 a.m. So आप join करें special class tomorrow for some more fun and good questions practice. If you want all my special classes, then go to this particular URL. On the team is giving you every single thing for your computer science preparation. It is giving you GATE preparation full length mode. Another crash course is going on, means 3 months, 3.5 months we are going to complete all the syllabus. Then we are giving you semester courses also, we are giving you machine learning also, we are giving you placement batches also. All entire package this particular team is giving you. So what you need to do yaar, aap in sare lectures ko share karo. If you want to learn COA, computer organization architecture, in really great series of 52 lectures I have recorded already. Just go and watch it. It's amazing series. You watch all the lectures and you will learn COA in the most effective manner. If you are preparing for your GATE and if you are really interested in effective learning means, sir, we want to spend only 8 hours, but we want to achieve what we want to achieve is very large, too much as compared to 8 hours study. So here is the solution is Unacademy Plus. When you come on the Unacademy Plus, your 8 hours will be as effective as your free source learning of 12 hours, 13 hours, 14 hours also, just because we will save a lot of time by giving you so many short tricks, giving you so much explanation of the topics so that you don't have to waste your time. Will give you lots of doubt solving so that you will not waste your time here and there for discussion with multiple channels. Plus we will be giving you so many questions to solve so that you will not face any kind of problem in understanding any topic. All these things come under Unacademy Plus subscription: live classes, crash courses, Hindi English batches, rank improvement batches, doubt solving, weekly tests, and so many practice questions from our end. And all these you can get in discount if you use the code VDEEP10. ये कोड आपका जो है वो आपको देगा 10% discount. Plus this particular code will give you my mentorship, who has written the GATE multiple times, cracked it with really good rank. So I know in and out how you will prepare for GATE, how you will target the GATE exam so that you will be getting more marks in less time, in less efforts. Plus, you will be getting my entire team support. Yes, you will be getting the support of my team. And how you can get it? If you use the code VDeep10 and get the Unacademy Plus subscription done. Do it as soon as possible. You will be learning to the maximum possible effective manner. If you are the person who is not able to assess your own mistakes, who are not able to understand how to prepare a strategy or planning, then there is another type of subscription, which is iconic subscription. This iconic subscription is including all the benefits of plus subscription, and apart from that, there will be a personal coach given to you from an academy side. That particular personal coach will give you preparation strategy, personalized one, so that based on your own understanding, your own learning, you can go and prepare. Apart from that, that fellow will give you the planner, the planning of the day-to-day activity. This time you will study this course, then this time you will study this course, this time practice, and so on, and will give you study booster sessions, so that regular workshop will help you in your essential learning, effective learning. Personalized test analysis, so if you have made some problems, made some mistakes before, those mistakes can be overcome. Plus, preparation study material also will be given to you, so that you will have to focus only on one thing, which is practice and study, understanding, practice and all. So iconic subscription, if you want to go for, then iconic subscription also you can get into discount, which is VDeep code. Agar aap use karenge, VDeep10 is the code which you need to remember and which you need to use for all the plus subscription, so that you can get lots of benefits. याद रखें code को. And now let's start. Let us start the course. चलिए, तो if you are ready, I know you are ready, so you need to show some kind of excitement, some kind of enthusiasm, some kind of energy. If you want me to teach you with the energy, you should also have some energy. ऐसे सुतर मोड में नहीं रहने का रे. Okay, so come on, get up, wakey. Good morning, everybody. Very good morning. If you are ready, type down in the comment box you are ready, so we can start. Jaldi send me a message, send me a comment here that you are ready, so that we can start the class for the day. Are you ready? Ready. Okay, one person ready, remaining बाकी के कहाँ हैं भाई, सो रहे हैं क्या? So recap what we did yesterday. We have seen push and pop. We have seen what is the top and bottom pointer. Then we have seen implementation of stack using array. Then we have seen implementation of stack using linked list, and at the end we have seen the stack permutation. Now we are going to have two more basic things of the stack, which is very important for your learning. So stack हमने कल देखा था. Now this is the question. Based on this question, I will be explaining you how to implement a queue using the stack. There are two methods. Then you only at the end decide that you only will be deciding that which method is better in terms of efficiency. At the end आप लोग बताओगे yes, ready. Okay, that's great. Now, what is the minimum number of stacks of size n required to implement a queue of size n? What is your answer? आपका आंसर क्या है बच्चा, बता दो जरा. What is your answer? Answer is 2. Two number of stacks are required to implement a queue. And how those two stacks will be implementing the queue, that particular thing I am going to explain here. How an implementation of queue happens using the stack. Right. So basic method. First of all, I am going with the regular method. What regular method says? Regular method says like this. I am not giving you any kind of algorithm or something. I will just explain you the method. After that, you will tell me ki sir, this method is not good, next method is good, or next method is not good, this method is good. Based on that, we will check it out. Okay, so regular method says two stacks are there. Fine. Okay, let me draw two stacks. First one, oh, थोड़ा सा दूर हो गया, मिला दो इनको. Fine, these are the two stacks. Now in these two stacks, I want to implement the queue. So this is my stack number 1 S1 and this is stack number 2 for the insertion NQ. Okay, for NQ what I will do, insert blindly in S1. For NQ, what I will do, blindly insert in S1. So if suppose the sequence of operation we have like this way, suppose I am having an NQ of element A, then I am having NQ of element B, then I am having NQ of element C, then I am having a DQ and then another DQ, then NQ of element suppose D, then another NQ of element E, then another DQ. If these are the operations I am having, how will I perform these operations one by one? I will tell you. मैं बताता हूं आपको. NQ blindly insert in stack S1. So blindly insert in S stack S1A, done. Then NQB insert B. Then NQC insert C. Blindly insert S1. That is the NQ method. Now if there is a DQ, we need to perform the DQ of the front element. The Q is first in first out, which means whichever element you have inserted first, that should be deleted first. So what element you have inserted first? A. So deletion should be A. But can I delete directly A from a stack? No, I can delete from a stack last inserted element, which is C. So what we will do, we need to actually reverse the order of all these elements, and hence because of this another stack is required. To reverse the order of all these elements, we need another stack. So what we will do for DQ, we will bring all the elements from S1 to S2 so that the topmost of S2 will be that element which you inserted first. Then from S2 you can delete the element which will eventually perform your DQ from the front. And after that you need to bring back all the elements in the S1. So what is the DQ operation? DQ operation is all the elements bring from S2 to S1, one by one pop from S1, one by one push into S2, and after that at the end pop from S2. I will show you by the method. Look at this. First of all, pop C, bring it here, pop B, bring it here, pop A, bring it here, and now you need to pop A so that A will be DQ. So this DQ, okay, A is deleted. Now what I need to do, this is done, this is done, this is done, this is done. What I need to do is bring back all these elements here. वापस से लेके आओ. So B will be here, C will be here. So after DQ, what we will have? S1 remaining elements, S2 nothing. Now what we can do is for next operation, what is the next operation? If you learned the methods, I am repeating again what I am doing exactly. For insertion in the queue, I am inserting in S1 directly. Deletion in the queue, what I am doing is bring all the elements from S1 to S2 so that elements are reversed. Then from S2 topmost element deleted. Then again bring back all the elements from S2 to S1. That is my method. That is my method of implementation. Now what I am going to do, another DQ. For another DQ, what I will do, bring C here, bring B here, and topmost element B deleted from here. And then again in the reverse order bring back all the elements back to here. See. Then NQD, NQ के लिए क्या करना है? NQ means insert here. Then NQE, insert here. Then another DQ. If another DQ is there, what should I do? DQE or delete E and bring it, hit D, bring it here, delete C, bring it here, and topmost element C deleted. Now post element C deleted. Now bring back all these elements here. So in the bottom you will be having D next. That is the regular method. Should I write down this particular method? Okay, I will write it down. The regular method I am writing down. So what is the NQ method? NQ means push the element onto the stack. Push onto S1 blindly, no any other thing. Nice, nice, nice. DQ. What is the DQ? What I am doing in the DQ? Bring all elements. From where to where? कहां से कहां लाऊं? बताओ जरा. Bring all elements from आपके घर से मेरे घर में. अरे नहीं रे बाबा. Elements from S1 to S2. Then a pop from S2 and then bring back remaining elements, of course. Bring back remaining elements. कहां से कहां पे? Remaining elements from where to where? Remaining elements from S2 to S1, so that in the S1 we'll be having all the elements back. That is the regular method. But in this method, in this particular method, सर ये लेक्चर कैंपस प्रिपरेशन के लिए है. देखिए कैंपस प्रिपरेशन के लिए डेटा स्ट्रक्चर इज मस्ट. सो इफ यू हैव अ बेसिक ग्रिप ऑन डेटा स्ट्रक्चर, ऑफ कोर्स इट कैन हेल्प you in any kind of campus preparation. So of course all the members who are preparing either for GATE or for placements, you should have a good grip of data structure. These lectures can help you in that. Now listen, what I told, in this particular method, number of push and pop are so many. For DQ operation, when you are going for DQ, in the DQ operation, number of push and pop are so many. बहुत सारे push and pop हैं. आप ये push and pop कम कर सकते हैं. You can reduce it by using a very efficient method, and that I am going to tell you now. That I am going to explain you now. Another method, that particular method can give you better than this efficiency, means in terms of number of operations. When you go for DQ, n elements you are popping, then n elements you are pushing here, then one element you are deleting from here, then again n minus 1 elements prop from S2 and bringing into S1. It is too much. It is too much. Now that too much we will reduce by another method, which is efficient method, which I am going to explain now. Sir, efficient method alag hai isse? Yes, alag hai, different hai. And that efficient method will definitely have less number of push and pop as compared to the previous version. Okay, now what is efficient method? How it works? Let me explain you first, फिर आपको समझ में आएगा. Okay, so let me explain first, then you will understand it how it works. So two stacks again you are having, and now suppose if you are performing some sequence of operation exactly as previous time I have written, same I'll be writing this time also. चलो लिख देता हूँ. What operations I am going to perform in the sequence? Operations are like this. First of all, I am going to perform NQ of A. Then I am going to perform NQ of B. Then I am going to perform NQ of C. Then I am going to perform a DQ. Then I am going to perform NQ of D. Then NQ of E. Then two DQs. These are the operations I am going to perform. So if these are the operations which I am going to perform in the efficient method, how the efficient method works? See, in efficient method, the push is same to same as the previous one. Push is same to do. Insertion, NQ is exactly same to same. NQ is exactly same to same. What is NQ? NQ क्या था पहले? जल्दी से टाइप करके बताओ. You remember? Test your memory रे बाबा. आपका memory तो टेस्ट करें. What was NQ previously? Push blindly in S1. Push blindly in S1. So first is NQA, blindly push on S1. Done. Then NQB, push it on stack S1. B. NQC, push it on stack S1C. अब बढ़ते हैं आगे. DQ method will be changed. DQ method will be changed, and what is that change? DQ method, look at this, concentrate here and just try to understand. First half is same to same. First half same to same है. If you want to DQ an element, of course, the elements from S1 to S2, yes, we need to bring. What we will do from here is we will pop one by one element from S1, bring it to S2, pop B, bring it to S2, pop A, bring it to S2, and after that the topmost element popped. Bring all the elements from S1 to S2, and after that topmost element, of course, that is your what? The first inserted. Deleted, yes, deleted. Previously, यहाँ पे हम क्या कर रहे थे? At the end, when we were performing the operation of DQ, we were bringing all the elements from S2 to S1 back. Now in this efficient method, we will not bring. In the efficient method, we will not bring the element from S2 to S1 back. We will keep it there only. Still, see why we brought the element from S1 to S2, so that in the S2 you can have the topmost element. Which one? Topmost element, the first inserted element. So if another DQ comes, we will not bring S2 to S1 elements. Just check out. We will just check out ki S2 is not empty. No, not empty. S2 is not empty. Then pop element from S2. You will delete the front element of your queue. Front element of your queue will be deleted. Okay, so what I was saying, ki if you are using the efficient method, in the efficient method, you will be having, what? You will be having very simple solution. That is what? Don't bring the elements from S2 to S1. Don't bring the elements from S2 to S1. Just do one thing. Just keep the elements into S2 only. You can see that on the topmost in the S2 you have the first inserted element of the remaining Q, which is B. So what we will do in the pop operation, in the DQ operation, we are going to check key is S2 non-empty. Is S2 is not empty? No, S2 is not empty. Then directly pop directly from S2. So this is done, this is done, this is done. Now you are doing this one done already. Now you are trying to DQ. So what we need to do in the DQ, you need to just check out ki S2 is not empty. No, then directly pop the topmost element. Now it will not be lag, I guess. अभी ठीक चल रहा होगा. देखिए, is that fine now? It will not lag now, I guess. So what I am telling you here is कि if the efficient method is there, from S2 to S1 we are not bringing back the elements. From S2 to S1 we are not bringing back the elements. What we will do is we will check out ki if S2 is empty, then only we will bring elements from S1 to S2. If S2 is not empty, directly S2 के top को उड़ा दो, directly delete the topmost element of S2 and you will be having a DQ of the Q. Suppose next is NQ. NQ is what? NQ method क्या है हमारी? NQ is insertion in the S1 stack. Do it. Insertion in the S1 stack. Then NQE, insertion in the S1 stack. Then after that DQ. For DQ, what we are going to check? S1 is not empty. No, pop it from here. Pop the element directly from here. C will be deleted, which was my first inserted element among remaining. Now, thing is another DQ comes. This particular DQ says that check out S2 is empty. Yes, S2 is empty, means there is no any element in S2. Yes, in that case only you bring the element from S1 to S2. So bring all the elements from S1 to S2. E here, right? D here, and after that delete D from the top. In the DQ, you will be deleting D, but you need to bring elements from S1 to S2. Why? Just because S2 got empty. Abhi likh raha hu main method. I am going to write the method of NQ and DQ. You guys are going to understand what is that. Method of NQ is nothing but push onto S1. That's it. That's it. Nothing. Exactly same to same as the previous one. Suppose we want to perform DQ. If we want to perform DQ, we are having two clear-cut cases here. First case is if S2 is not empty, DQ or delete or pop from S2 stop and my first inserted element deleted. Okay, so I am writing the first statement in the DQ. The first statement is this: if S2 is not non-empty, S2 is not empty, then what I am going to do, I am going to pop from S2. Pop from S2 and work done. वर्क हो जाएगा खत्म. अभी बात करते हैं सेकेंड पॉइंट की. इफ S2 is empty then what we are doing? If S2 is empty then what we are doing? If S2 is empty, we are going to bring all the elements. Bring all elements from where to where? All elements from S1 to S2 and then pop from S2. Right? Right? And this particular efficient method can save your lot of push and pop operations. Why? Just because you are not bringing all the elements from S2 to S1 back. You are not bringing all the elements from S2 to S1 back. Did you understand this method? क्या आपको ये method समझ में आई है? जल्दी से मुझे बता दो so that we can go further. Did you understand this method or not? Or should I quickly recap it? Okay, चलिए quickly revise करवाता हूँ. S1 or S2, two stacks are there. For NQ, push the element in the stack S1 blindly. Second thing, if you are going for DQ, you check out if S2 is having some element. If S2 is having some element, pop an element from the S2. Directly my first inserted element will be deleted. If S2 is not having any element, then bring the elements from S1 to S2 and then after that you pop from top of the S2. In that case, you will be able to do the DQ. Of course, from the previous method, this one, we can save a lot of push and pop operations here. Okay, now is that clear? Clear, clear, clear. जल्दी से message कर दो यार, clear है कि नहीं, so that we can go further. आगे बढ़ पाएं, आगे बढ़ पाएं, आगे बढ़ पाएं. चलिए, चलिए, जल्दी से. Okay, fine. So this is the algorithm which just now I explained you. It was given in a question 2006 का GATE question था. I will explain you its solution also. But first of all, just understand the method. Same to same method which just now I explained you. An implementation of a queue using two stacks S1 and S2 given below. Implementation is like this. Insertion in the queue, element X. What I am doing is push onto S1 element X. Same to same मैंने बताया. Then for deletion, I am checking if stack S2 is empty. If empty, then we need to bring the elements from S1. But first of all, we will check क्या S1 भी empty है. If stack empty S1 is also empty, then we can say that Q is empty. There is no any element for deletion and return. If suppose S1 is not empty, if suppose S1 is not empty, S2 empty, S1 is not empty, in the else part, we are bringing all the elements from S1 to S2. Look at this. While not empty, stack S1, pop from S1, push to S2. So all the elements from S1 to S2 we need to bring and after that we will pop from S2. Suppose stack S2 is not empty, then if condition false, yes, we will go inside directly. No, we will go outside directly and we will do what? We will go for this pop directly. So if S2 is not empty, pop directly. If S2 is empty, check out if S1 is having element, then bring all the elements from S1 to S2 and pop from S2 so that your first inserted element deleted. Exactly this method I just explained you. This is the only they have given in the question. Now if you are clear about the method, we are having some kind of question based on this method. Question is, let n number of insertion and m number of delete operations be performed in an arbitrary order in empty queue, and m is less than or equal to n. Right? Okay. In the empty queue, you are inserting n elements and then deleting m elements in some order, arbitrary order. X and y be the number of push and pop operations performed in those process. Which one of the following is true for all m and n? Right? Now, if push and pop operation we need to calculate, the conditions given based on this is x number of push and y number of pop operations we are having. Look at this, the condition is x value can be minimum this one, maximum this one, y value can be minimum this one, maximum this one. Means these are nothing but minimum push and pop operations are how many and maximum push and pop operations how many required in different cases when we are performing insertion and deletion in an empty queue. How many insertions? N, m delete operations. यहां पे मैं आपको बताऊंगा इस क्वेश्चन का सॉल्यूशन इन टू डिफरेंट वेज. वन इज द बेस्ट केस where we will be having the minimum number of push and pop operations. Then I'll be going with the worst case. Then in worst case we'll be having maximum number of push and pop operations. Once I will explain you ki what is the best case and worst case, after that I will explain you ki why that is best case and why this is worst case. Pehle cases samjhenge, we will understand the cases first, and after that I will explain you ki why these cases, this one is best and this one is worst. At the end you will understand, I will explain, you will understand. Look at this now, the solution. Let's see the worst case first. Let's start with the worst case first. The worst case means maximum number of push and pop. Okay, now listen. First, I am just explaining how many push pop. After that, later on at the end, I will explain key why these many push and pop and why this is worst case. So, worst case scenario is like this. Key first insert all n elements. First, insert all n elements. And then delete m elements, whichever m elements you want to delete. Let's take a simple example. Simple example लेते हैं और अच्छे से समझ में आएगा. Let's assume n is equal to 100 and m is equal to 60. Means आपको 100 एलिमेंट इंसर्ट करना, 60 डिलीट करना, 40 will be remaining. You need to insert 100 elements, delete 60, remaining 40 will be there in the queue. Now, first of all, insert all n elements. If you understand the method, if you remember the method, what I told you for the insertion means push onto stack number S1. Right. So this is a stack S1, this is a stack S2 for the push or for the insertion. For the insertion of n elements, what you are doing is you are having only push operations. How many push operations? N. I guess this is clear to everybody. Is this clear to everybody? Type down in the comment box. Type down in the comment box if this is clear or not. Type down in the comment box if this is clear or not. अरे clear है तो बोलो रे बाबा. Okay, now let's come back here for the deletion. For deletion, what I told, if you have inserted all n elements, means n elements are present here. For deletion, S2 is empty. Yes. First of all, my method is bring all elements from S1 to S2. Yes. First of all, if you are bringing all elements from S1 to S2, पहले तो S1 से pop, right? So one by one pop. How many pop you will do? N pop. Then after that, those n elements will be pushed onto stack S2. Yes. So how many push to bring the elements from S1 1 to S2 n push, and after that all n elements are here, all 100 elements are here, you need to delete only 60. Deletion says what? If S2 is not empty, pop first element, then S2 say he pop next element, then S2 say he pop next element, next element, next element. We have more than m elements in the S2, yes. So for each deletion, what you will do, you will perform only pop, 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 pop. And how many pops? 60 pops means m number of pop operations you will do for the deletion of those m elements. Total count करो जरा कितना आ रहा है, टोटल काउंट तो करो जरा कितना आ रहा है। तुम लोग आज लगता है चाय नहीं पिए सुबह सुबह, चाय पिए क्या सुबह सुबह? कोई मैसेज नहीं, कोई आपका चैट नहीं, एनर्जी नहीं, एक्साइटमेंट नहीं, समझ में आ रहा है आप लोग को? आर यू गाइज अंडरस्टैंडिंग? आर यू गाइज एंजॉइंग? सी, इन माई क्लास आई ऑलवेज ट्राई सो दैट यू कैन लर्न, you can enjoy learning, you can make the learning happy, which is my personal favorite quote, happy learning. So मैं चाहता हूं कि आप जागो यार, जागो भैया जागो, आंखें खोलो. Okay, so total how many push operations and pop operations? Look at this. How many push? Calculate karo total. How many push? N and N, 2n. And how many pop? Total pop operations are n plus m. Great. Everything clear? Good, 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 good. So total push number of push operations are 2n. Total pop operations are n plus m. I have counted separate. That was the worst case. Sir, worst case क्यों था? अरे थोड़ा रुक तो जाओ, 5 मिनट रुको, पहले best case समझाऊंगा. I'll explain you the best case. After that I will compare both the cases. Okay. So worst case, maximum number of push we can have 2n, maximum pop we can have n plus m. Let's see. 2n 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 for maximum push सारे ऑप्शंस में है, n plus m n plus m n plus m here and here, means either A option or C option is correct. Let's see now the best case and we will be able to understand कि what case will give you what answer based on the different cases. चलिए, तो best case के बारे में बात करते हैं. Best case says that best case is exactly same method which your mom uses with you. If you need one biscuit, she will bring one biscuit only for you. She will not show all the biscuits to you कि how many biscuits are there in the house. मम्मी भूख लगी, एक लड्डू दे देना. Mom will give you only one laddu. You want more? Okay, she can give you more. But if you want only one, she will give you one only, and she will not show all the laddus that where the laddus are and how many laddus are available in the house. Nah. But worst case is like she is serving some kind of food, some biscuits, some laddus to the guest. So if they will require one only, she will bring 5. आपका फायदा है उसमें, 5 में से 4 तो तुम खा जाओगे बाद में, जैसे ही मेहमान गए टूट पड़े. Right? Okay, now listen. Now listen. Best case is what I am saying. Among n number of elements, among 100 elements, how many you are deleting? Only 60. So if you are going to delete only 60, you first insert only 60 and delete them. First insert 60 and delete them, which is I am going to write here. First insert m elements and then delete them. After that, insert remaining. How many remaining elements? If n is total number of insertion you should do, among those you have done only m, remaining n minus m elements. Later on you will insert. फाइन. चलिए, फायदा क्या होगा? आई विल टेल यू फायदा क्या होगा. लुक एट दिस. फर्स्ट ऑफ ऑल, यू आर डूइंग फॉर इंसर्शन. फॉर इंसर्शन व्हाट you will do? For insertion, what you will do? For insertion, you will do push, right? So initially you have pushed m elements for m insertion. After that, remaining n minus m elements you have pushed later on. Total n elements you have pushed in and all. Right. Abhi deletion. अभी डिलीशन देखते हैं. आई विल एक्सप्लेन यू यूजिंग सम विजुअलाइजेशन. लुक एट दिस. These are the two stacks I am having. Using those two stacks, I am trying to implement the queue. Look at this. This is S1, this is S2. You have inserted initially M elements here. Only M, 60 elements, suppose in my example. Now you want to delete. S2 is empty, yes. So how many elements you will bring from S2 to S1 initially? How many? All means how many? M or N? M elements. M elements. For deletion, you have performed the first pop of M elements, right? Then push of those M elements into S2. So bring all those M elements from here to here, right? Okay, and then brought these elements here, fine. And after that, you need to delete those one by one. So pop those M elements from S2, right? Right, this is done, this is done, this is done. Now count total how many push and pop operations you are having. Total how many push and pop operations we are having. Let's take it out, let's check it out. Total push and pop. Let's see, push कितना हो गया? Push n here, m here, n plus m. And how many pops? How many pops? How many pops? 2m pops. So these are the minimum push and pop. Minimum is n plus m and minimum pop is 2m. Okay, so minimum is n plus m. यहाँ पे मैच कर रहा है A option. Minimum pop is m. Option A is correct. Option A is correct. Option A is correct. Now I will differentiate ki why first case is worst case and why the second case is best case. Understand this example. 100 elements I am inserting. 60 I am deleting. How many remaining? 40 should be there in my data structure. Yes. The worst case says you insert all 100 elements here. All 100 elements you have inserted initially. When you have inserted all 100 elements, then for one deletion also you need to bring all 100 elements from here to here. Yes, all 100 you have popped from here, you have brought here. Among those 100 you have deleted 60. Why? Just because I had to delete only m elements. So I have deleted m means 60 elements. How many remaining? 40. Where you have kept those 40 elements? Where these 40 elements are? Those 40 elements are in S2. Look at this. I didn't want to delete those 40 elements. I did not want to delete those 40 elements, but still I brought from S1 to S2. Yes, ये है मेरा extra effort. That was my extra effort. Extra effort. Why? Just because the elements which I did not want to delete, those also I brought from S1 to S2 40. So for those 40 elements I brought from S1 means popped from S1, pushed into S2. Extra time laga. That's why extra operations push and pop required in this case. In this initially we have inserted 60. Those 60 we have brought from here to here. So how many we brought in S2 from S1? Only 60, which we wanted to delete. After that we have deleted all 60. Yes, done. There is no any element in S2. Now remaining 40 elements we are inserting again in S1 later on after all the deletion. Means where these 40 elements are in the stack S1, means I am not bringing those 40 elements from S1 to S2. Am I saving time? Yes. Am I saving time? Yes, I am saving time here. I am saving the push and pop operations here. That's why this particular case is best. That's why this particular case is best. समझ में आया कि नहीं? अरे बांगड़ू बोलो रे. बांगड़ू means a शिष्य, a student. So if you understood, ये रहा मेरा फोन, मैं चेक करता रहता हूं आप लोगों की कमेंट्स. जल्दी से मैसेज कर दो. डिड यू अंडरस्टैंड व्हाई द केस इज फर्स्ट बेस्ट केस और सेकंड वन इज वर्स्ट केस और फर्स्ट वन इज ऑफ कोर्स बेस्ट वर्स्ट. Did you understand why this is worst case and this is best case? Understood or not? Answer is A for this question. Of course, such kind of questions will be very tricky if you'll be getting such kind of questions in the gate, but it was a history that from the stack and queue, there are 2 to 3 questions which have been asked in the gate exam, and those were very tough. Very, very tough. बहुत tough थे, and those questions either you had to solve at the end, maybe 20-15 minutes it will take to get 2 marks, or maybe you will not get appropriate time to solve such questions if you are taking so much time for other questions, but still you can try and you can get the answer if you are clear about the method. आगे बढ़ते हैं, अगली चीज देखेंगे, multiple stacks in a single array. So if one array is given, in the single array we are trying to implement 2 stacks. How we will implement it? How we will implement it? ठीक है. Now the thing is, ऐसे क्वेश्चंस को आपको डायनामिकली सोचना होगा. The new question, if tough question, new question, this kind of question comes, you need to think dynamically. There is no any appropriate approach कि you need to follow this only for such questions. Just because it's a unique, peculiar type of question, again it will not be repeated, but still you need to think of what? You need to think of the method, understand the method, and based on that you need to come up with some kind of dynamic solution, kind of an aptitude type of solution which you can apply so that you can get the answer. बात करते हैं multiple stacks in single array. So you have right now, instead of multiple stacks, I am going to implement 2 stacks initially so that I can explain you the method. After that I will tell you how you can go with more than 2 stacks also. So if you are using the multiple stacks in single array, you have 2 methods. Method number one, the method number one says that you are having an array of size n. You divide this array into 2 equal halves. Divide the array into 2 equal halves, and first half is given for first stack, second half is given for second stack. It's like in the starting of the class when I told na pasta wala example. Suppose you and your best friend went for a particular restaurant. Went to a particular restaurant. You have ordered one plate pasta. The friend is sitting next to you. You are sitting this side. You don't trust to your friend. Your friend also don't trust on you. What you need to do? Divide the pasta into 2 equal halves. That is yours. This is mine. I will eat mine. You eat yours. The pasta is there. Maybe you can take any example. यार मैगी ले लो, पास्ता ले लो, पोहा ले लो, whatever you want. Whatever you want, you can take upma also. One plate, in a big plate, you are dividing into 2 parts. This is yours, this is mine. Equal part. You eat yours, I will eat mine. I will eat mine, you eat yours. That is the simple division you have done. So what you've done is divide array into equal halves. Divide array in equal halves, and what you will do is assign each half to each stack. तो एक एक हाफ जो है आपको स्टैक अलग अलग स्टैक को दे देना है. मीन्स इफ यू आर हैविंग 2 स्टैक्स, दिस पर्टिकुलर हाफ इज फॉर स्टैक नंबर 1 and the remaining half is for stack number 2. Suppose you have n number of size of array, then suppose you have indexes from 0 to n minus 1, then this particular first half will be up to n by 2 minus 1, and the remaining half starts from n by 2 to n minus 1. Got it? 10 size array, suppose you have 0 to 9, then 0 to 4 will be given to first half, first stack, and 5 to 9 will be given to other stack. So in that particular case, initial case will be what? Initially, when stacks are empty, Initially, when stacks are empty, in that particular case, what will be the value of top 1 and top 2? Top 1, the first stack's top 1 will be on the index -1, and it will grow towards what? It grows towards n by 2 minus 1. Means first element will be inserted on index 0, then 1, then 2, then 3, then 4 up to n minus 2. And similarly, top 2 will be where? Top 2 will be at n by 2 minus 1 index, and it grows towards which side? N minus 1 side. Means first element in the stack 2 will be inserted in index n minus 2, then n minus n by 2, then n by 2 plus 1, n by 2 plus 2, n by 2 plus 3, n by 2 plus 4, and up to n minus 1 stack, n minus 1 index, we can store the elements. Okay, okay, fine. Now, this particular case will lead you to have a problem, and the problem is what? Suppose your friend is too fast to eat. आपका जो दोस्त है वो बहुत जल्दी खा लेता है. So that fellow has completed his first half, whatever the half given to him or her, that fellow completed. Now you are having still some of the pasta or some of the poha or upma or something left. That fellow will definitely try to grab it, right? But you cannot give it, right? Yes. Suppose you are not hungry, but still you will say, no, you cannot eat my part. नो आप मेरा पार्ट नहीं खा सकते, नहीं मेरे को देना ही नहीं. होता है ना, सिबलिंग्स में ऐसा होता है, right? Brother sisters fighting like that only. If I am not eating, you will also not eat this particular portion. You nobody will eat. If I am eating, I will eat. Otherwise, you will not allowed to eat. Okay, okay. So what happens? Suppose stack 1 is full. Stack 2 is having only few elements. Remaining this particular portion is free. You can see this particular portion. Suppose this particular portion is free. Stack 2 is not full. Stack 1 needed more space. Not at all possible, just because stack 1 is limited to its assigned size, and hence I can say here this particular solution is not using. This particular solution does not use space efficiently. This particular solution does not use the space efficiently. If it is not using the space efficiently, then how we can go for is another solution, and that solution says ki you don't divide the array into two equal halves. You don't divide the pasta into two equal halves. Take the plate, ask your friend to start from that end. I will start from this end. I will eat, that fellow eat. If any pasta is remaining in between, we will try to eat it. If nothing is remaining, done. Now it might possible that your friend is eating more, I am eating less. Might possible I am eating more, your friend is eating less, but my entire pasta is finished. Means in the second method number 2, I am going to have such implementation where efficient usage of space is required. What I will do, I will go with this key start arrays, stacks, start the stacks from two different ends, stacks from two different ends. Right? Okay, so if you will be going with this way, suppose this is the array, I am having single array. If I want to utilize the complete space of the array, index are 0 to n minus 1, then initially top of the stack S1 will be on the index number -1, and this top will be on n, top 2. This stack first will grow this way, and stack number 2 will grow this way. Simple as that. Abhi suniye. Initially when both the stacks are empty, In that particular case, what will be the value of top 1 and top 2? Top 1 will be pointing to -1 and top 2 will be pointing to index n, which is this side. So this -1 will grow towards what? Grows towards which side? 0, 1, 2, 3 up to n minus 1, and top 2 grows towards 0 this way. Right. Now, if I want to write down the overflow ka condition, if I want to write down in this particular array, in this particular two stack combination in the single array, if I want to write the overflow condition, what will be the overflow condition? बताओगे आप? आप लिख पाओगे? See, overflow means the stack is full. Stack is full. And when I can say stack is full, no any space is there in the array. No any remaining space in the array means entire pasta is done. Means this top one is increasing to index 0, 1, 2, 3, 4, and somewhere here top one is pointing. Top one is pointing to some index I, and top 2 is pointing to that index I plus 1 on the immediate next index. If at immediate next index top 2 is present, which means there is no any space in between top 1 and top 2, no any next element can be inserted. So what should I write? Top 1 is equal to top 2 minus 1. Or in other terms, I can write down that top 2 is equal to top 1 plus 1. Got it? Got it? Got it? Both cannot point to the same index, otherwise there will be an overlap. Means the topmost element is on that index only of first stack, and second stack also, that is not possible. दोनों stack के elements अलग अलग होंगे. Both the stacks are having different elements. So stack 1 will be having its top somewhere, stack 2 will be having its top somewhere, and both the tops are on the next to next index. So that I can say it's an overflow. Can you tell me what is the underflow condition? It's very simple, already written over here only. Underflow means stack is empty. What is the underflow condition for the first stack? It will be top 1 is equal to what? Top 1 is equal to -1. For the second stack, it will be top 2 is equal to n. If top 2 is here nth index, then stack 2 is empty. If top 1 is equal to index -1, then this is empty. Top 1 is empty, stack 1 is empty. Okay, fine, understood. Here we can utilize the space properly. Why? Just because stack 1 is growing from this way, stack 2 is growing from this way. If in the middle you have free space, any stack whichever requires the element next, that stack can use the empty space in between. Empty space को utilize कर लेंगे, and hence better utilization. So I can say here, I am writing here in this particular better space utilization we have. Better space utilization. Got it? Clear hai? Now the thing is, if you have more than 2 stocks, more than 2 stacks if you have, then you cannot implement this. Why? Just because this we are having this way. 2 stacks trying to grow from 2 different ends. So in the array we have only 2 ends. Fine. So 2 stacks we can start growing from 2 different ends. But if you have more than 2 stacks, you cannot go with this way. You will have to go this way only. So this particular method is good. I'm writing it's good when more than 2 stacks to be implemented. If more than 2 stacks to be implemented. So remember, if more than 2 stacks, we'll have to implement 3, 4, 5, 6, 7, as many as we want, then we will have to divide the partition. We need to divide the array into partition. Each partition will be given to one particular stack. That stack can store its element into that partition only. That you need to understand. Okay, fine. चलिए तो फिर एक ये क्वेश्चन है जो गेट में आ चुका है, exactly same thing which just now I explained you कि if you have the stack growing from two different opposite ends, the size of array is 1 to max size. Instead of 0 to n minus 1, they have taken 1 to some max size n. Then in that case, if top 1 is pointing to the topmost element of first, top 2 is pointing to the topmost of second, which particular case will give you stack full condition, means overflow condition, when you are using the or utilizing the space efficiently. Just now here only I have explained top 1 is equal to top 2 minus 1. आपको easily अब समझ में आ जाएगा. I want one particular thing from your end. You try and understand कि why this particular option will not give you correct option, why not this one, and why not this one. You just verify this, convince yourself by giving some example, taking some example and explaining yourself कि yes, these three options are incorrect in these cases. Try and do it. If you will do it by yourself, of course your learning will be amazing. Of course your learning will be amazing. ठीक है, अब बात करते हैं आगे की, कल हम क्या करेंगे. ओके, ये तो ये सारी चीजें तो हो चुकी हैं. Tomorrow we are going to have the expression. So I guess tomorrow there will not be any class. I will tell you well ahead if there will be a class tomorrow or not. If there is no any class tomorrow, then we will meet on Monday again. From Monday onwards, there will not be any problem in our this particular class. We'll be having our regular class. Just because of some other commitments, I am facing some kind of problem of irregularity. But tomorrow, I guess if will be there class, you can present here. If not, then we will meet again tomorrow. Not tomorrow. Okay, we'll meet again on Monday for this data structure class. Apart from that, Gate Express batch is already going on. My class 715 COA. Today I am going to discuss about associative memory and main memory, multiple chips, horizontal, vertical arrangement and all. And in that I am going to explain, I am going to explain you why cache memory is used. All these things I am going to discuss today. Please join that particular class and we will learn a lot from there. If you want the PDF of all the lectures which we are taking, then you need to join this Telegram page. आपको ये Telegram page join करना पड़ेगा. It's a channel where we drop our classes link, our announce. If you will turn on the notification, you will be getting notification when I'll be coming for the classes. Share the videos with all of your friends if you are liking these lectures, if you're liking our teaching methods and the content. Like the sessions every time when you attend the sessions. It will help us to reach maximum number of students. Thank you so much for joining here. Thanks a lot. Happy learning. Keep learning. Bye bye everybody. Thank you.